Hello, college algebra students. Bryn had some issues with her internet trying to get her video uploaded, so I'm going to record a quick video to help her out so that you guys have something you can watch for slide number 2. In the question on slide 2, we're given a graph of g of x. I'm going to do my best to draw a quick sketch here. 1, 2, 3. 1, 2, 3. So the graph does something like this. Might not be perfect, but it'll be close enough for our purposes. The first question is whether the degree of g is even or odd. Well, the degree of a polynomial determines its end behavior. If you have a polynomial with an even degree, then your end behavior on the left and your end behavior on the right have to match. So either both of our ends would go up or both of our ends would go down. This is not what's happening here. If you have an odd degree, then your end behaviors should be opposite. So one side would go up, whereas the other side goes down. And it doesn't matter which side. So in this case, we're dealing with an odd degree polynomial because our left end behavior is going down, our right end behavior is going up. So part A is odd. Part B asks us to actually identify the end behavior specifically. So the first question says, as x approaches negative infinity, let me write this a little clearer. As x approaches negative infinity, y approaches what? So x approaches negative infinity is the left side of our graph. As x goes further and further left, closer to negative infinity, our y values are going down. So y is also approaching negative infinity. Then the second part of the question says, as x approaches positive infinity, y approaches what? So as x approaches positive infinity, we're looking further and further to the right. As our x values are going closer and closer to positive infinity, our y values here are going up. So we would have positive infinity for our y behavior. So that brings us to part C. Part C, believe it or not, actually has an error in it, and that is web class's fault. So part C is asking us for the intervals of increase. When we're reading our graph, we always read from left to right. So start at the left edge of your graph, which in our case would be negative infinity. So we're just going to envision, we're starting way down over here. Read your graph from left to right, and if your graph is headed in the upward direction, we call that increasing. So from negative infinity all the way until we reach this little point here, our graph seems to be heading upward. But then as we continue to read from left to right, it looks like it's going down, and then we reach another kind of turning point, and from here forward it looks like it's going back up again, all the way to infinity. Notice the arrow here on this side. So there are two different intervals on our graph that look like they're increasing. They are from negative infinity to negative 3, and from 0 to infinity. Now you'll notice I used parentheses. That's because the actual turning points themselves are not included, because specifically at that very point, this turning point here and this turning point here, we are no longer increasing. That represents the point where we stop increasing and we actually take a turn downward. So technically it's like our function is sort of flat at that point. Part D is a corollary question. Part D asks us where our function is decreasing. So we're still going to be reading from left to right, and the only place where our graph appears to be going down as we read from left to right is from here to here. So very similarly, this is the interval negative 3 to 0, yet we need parentheses because our endpoints are not included. Now, the mistake web class made was using brackets. They should have had parentheses here in the blanks, but they put brackets. So ignore that and just use your own parentheses.